Friends, today we are studying a new unit, that is unit 20, and topic is triangles. Yes, Pita. First point which we'll discuss are collinear and non-collinear points. First is collinear points, and second non-collinear points. Just what are collinear points and non-collinear points? The points which lies on a same straight line. For example, we have a straight line and 3 points: point A, point B, this is point C, D. You can see all these 4 points A, C, D, B. All points lies on the same straight line. So these are collinear points. So basically, the points which lies on the same straight line are known as collinear points. And non-collinear points, the points which are not lying on the same straight line. For example, here a straight line C and D. You have a point B, and another point is here C, F. Now the C, B, and D, these are collinear points, but C and F, these points are non-collinear. Clear, beta? Collinear and non-collinear points. The points which lies on the same straight line are known as collinear points. Yes. For example, A, C, D, B. These are collinear points because they lie on the same straight line. Okay. Next is non-collinear points. The points which don't lie on the same straight line are known as non-collinear points. For example, C. Right here O. This is line C, D, and this is point B. C, B, D. These 3 points are collinear points. But O and F, these are non-collinear points. Because point O and point F are not lines on the same line. Clear, friends? Next is triangle. What is triangle? Yes, Pradam. A closed figure bounded by 3 line segments is known as triangle. A closed figure bounded by 3 line segments. You can see this is a closed figure, and this figure is made by joining the 3 line segments: first, second, and third. Now name this triangle A, B, C. This is triangle A, B, C. A triangle is a closed figure bounded by 3 line segments. Yes, but now some properties of triangle. Triangle has 3 sides. 3 sides: first, second, third. A triangle has 3 sides, 3 angles, and 3 vertices. Now these are sides: first, second, and third. AB, BC, and C. These are 3 sides of this triangle. Now vertex. What is vertex? Where 2 line segments meet. The point where 2 line segments meet. This is point A. Vertex is A, B, and C. 3 vertices are A, B, and C. And 3 angles. First angle CAB, second ABC, and third angle ACB. A triangle has 3 sides, 3 angles, and 3 vertices. Now name all these sides, vertices, and angles. 3 sides are sides A, These are three sides. Now vertex of triangle, point A, B and C. A, B and C. These are three vertices of this triangle. And three angles. First angle is A, B, C. Angle B first. First angle A, B and C. Second angle B, C, A. B, C, A. And third is C, A, B. C, A, B. Clear, students? A triangle is a closed figure made by joining the three line segments. And a triangle has three sides, three vertices and three angles. So these are sides, vertex and angles. Clear, students? Next is classification of triangles. Classification of triangles means types of triangles. Next point which we'll discuss is classification of triangles means types of triangles. Yes, beta. We can classify the triangle in two ways. First, classification of triangle on the basis of sides. Then classification of triangle on the basis of angles. We can classify the triangle in two ways. First, on the basis of sides. Second, on the basis of angles. Now, first part is classification of triangles according to the sides. Classification of triangles or types of triangles according to sides. Next point is classification of triangles on the basis of according to sides. According to sides. Yes. Classification means types of triangles on the basis of sides. So on the basis of sides, we have three types of triangles. On the basis of sides, we have three types of triangle. First type is equilateral triangle. First type equilateral triangle. Yes, friends. What is equilateral triangle? If all the three sides of a triangle are equal in length. If, as you know, in triangle we have three sides. If all these three sides are equal in length, for example, here we have a triangle. Now length of the side is 5 centimeter, 5 centimeter, and 5 centimeter. So you can see all three sides are equal in 5, 5, 5. So this is an equilateral. What is an equilateral triangle? If all the three sides of a triangle having same length, is equal length 5, 5, 5. If all three sides are equal, then triangle is equal. equality triangle is if all three sides, if all three sides are equal. If all three sides are equal in length, then triangle is an equalated triangle. Second is isometric triangle. Isometric triangle. Isometric triangle. Yes, what is an isometric triangle? If two sides, of triangle are equal, then triangle is isometric triangle. For example, when we have a triangle, suppose this side is 5 centimeters and this side is 5, and length of this side is 4 centimeters. Now, in this triangle, two sides are equal. If two sides are equal in length, then triangle is an isometric triangle. What is in equality triangle? All three sides are equal in length. In isometric triangle, only two sides are. If two sides are equal. Yes, friends. Now, third type is scalar triangle. Scalar triangle. Yes, friends. Third type is scalar triangle. If all three sides are different in length, all three sides. If all sides are different, then triangle is scalar. Yes, friends. So let's see once again. We can classify triangles in two ways. First is classification of triangles on the basis of sides. Second type is classification of triangles on the basis of angles. So first is classification of triangle according to or on the basis of sides. On the basis of sides, we have three types of triangles. First is equalated triangle. If all three sides are equal in length, then triangle is an equalated triangle. Second type is isosceles triangle. If two sides of a triangle are equal in length, then triangle is isosceles triangle. And third type is scalar triangle. If all three sides are different in length, then triangle is scalar. Equalated triangle, all three sides equal. Isosceles, only two sides equal. And scalar, all sides are different. Clear, students? Now, since we will discuss few questions of exercise 74. Now, exercise 74. Yes, students. Exercise 74, your first question. Yes, students, open your books, page number 260. Yes, students, open your books, page number 260. Your first question is, in the given figure, name the. In this figure, we have a triangle L, M, and N. Question first, the triangle L, M, N. In this figure, we have a triangle. Now, in given figure, name part A. Vertices of triangle. Part A, name the vertices of triangle. Of triangle are L, M, and L, M, N. These are three vertices. Next is part B, sides of triangle. Part B, sides of triangle. Yes, what are three sides are LM, MN, and N. First is LM. Second side MN. And third is NF. These are three sides of this triangle. Next, part C. Name the angles of this triangle. Angles. Yes, the first angle is angle M. Write as L angle L M N. First, we put the symbol of angle L M and N. Second angle L. This one second angle M N L. M N and L. And third angle is N L M. N L M. This is first question of exercise 74. Yes, students. Next is second question. Your second question is classify the following triangles with respect of their sides. Now we have six figures in this question, part A to part F. Length of sides already given. So in each triangle, we will write the type of this triangle. Second question. First, we'll draw part A, B, and C. Question second. Part A. Now we have a triangle ABC. A, B, and C. Now length of this side is 3.6 centimeter. This side is also 3.6 centimeter, and this side is 4.2 centimeter. Now part B, we have triangle DEF. Now we have triangle D, E, and F. E, F. This side is 3 centimeter. This side is 4 centimeter, and this side is 5 centimeter. Next is part C. Now a triangle GHK. G, H, and K. Now length of this side is 3.2 centimeter. This is 4.8 centimeter. And this side is 3.5 centimeter. Now friends, so see all these three triangles A, B, and C. Length of each side is already given. Now write the type of triangle. Now in this triangle A, B, C, two sides 3.6, 3.6. Two sides are equal. In first triangle, two sides are equal. 3.6, 3.6, and third side is 4.2. So it means in this triangle we have two sides are equal in length. So this is an isometric triangle. So first is isometric triangle. Now in second part, now we have a triangle D, E, and F. First side is 3 centimeter, 4 centimeter, 5 centimeter. Yes, but in this triangle, all sides are different in length. 3, 4, 5. In part B, all three sides are different in length. So this is a scaling triangle. Scaling triangle. Next is GHK. First side is 3.2 centimeter. This is 3.5 centimeter and 4.8 centimeter. Once again, beta, all three sides are different in length. This is a scaling triangle. Scaling triangle. First is isolation triangle. Second is scaling. Part C again scaling triangle. The second question, part A, B, and C. Next friends, part E, F, and G. Next three parts. Number triangle PQR, part B. PQR 3.4 centimeter, 3.4 centimeter, and 3.4 centimeter. Next is part E. This side is 4 centimeter. This side is 3.2 centimeter and 3.2 centimeter. This triangle is L, M, and N. Next part F. Now triangle X, Y, Z. X, Y, Z. This triangle is 2.8 centimeter, 4 centimeter, and 4 centimeter. Now, on the basis of sides, side of length of each side is given. On the basis of side, write the type of triangle. Now, in first PQR, the side is 3.4 centimeter, 3.4 centimeter, and third side also 3.4 centimeter. So all three sides are equal in length. So this is an equalated triangle. Equalated triangle. All three sides 3.4, 3.4, 3.4. All three sides are equal in length. So this is an equalated triangle. Next is the side is 4 centimeter, 3.2 centimeter, 3.2 centimeter. Now in this triangle we have two sides are equal in length. So this is a isosceles triangle. If two sides are equal, triangle is isosceles triangle. Next is 2.4, sorry, 2.8 centimeter, 4 centimeter, and 4 centimeter. Again, if the two sides are equal, then again triangle is isosceles triangle. This is the second question of exercise 74. Next, okay, third question. Third question of exercise 74. Yes, friends. Third is, in third question, we have three parts, part A, B, and C. Now, in this question, measure the side of each one of triangle given below. And first, we will measure each side of this triangle with the help of scale. Okay. Then verify in each case that the sum of length of any two sides is greater than the length of third side. So before that, but now this is one main point of triangles. That is one more point about triangles is the sum of length of any two sides. Suppose we have a triangle. Here, suppose side of this is 3 centimeter, and this side is 4 centimeter, and this side is 5. Okay. Now, the sum of length of any two sides of a triangle is always greater than third side. It means if we add any two sides, according to this fact, if we add any two sides of a triangle, then the sum of these two sides is always greater than third side. Now, verify it. Two sides, T2 and T1. Add two sides. 3 plus 4 is 7. This is the sum of two sides. Our fact is, if we add the length of any two sides of a triangle, that sum is always greater than the third side. Now, sum of two sides is 3 plus 4, 7. And third side is 5 centimeters. 7 is greater than. If the sum of two sides is not greater than third side, it means we can't draw the triangle of given length. The fact is, sum of two sides of a triangle is always greater than the third side. So add any two sides. Add any two sides. Now after adding, see the third side. The sum of two sides is always greater than the third side. So in third question, first, with the help of scale, measure each side of this triangle. Measure the length of each side of given triangles, then verify. Add any two sides. Now you can see the sum of two sides is greater than the third side. So after this lecture, complete question number 3. First, with the help of scale, you will measure each side. Then add any two sides of a triangle and see sum of two sides of triangle is greater than the third side. Okay. Next is fourth question. Is it possible to form a triangle by 3 line segments of the following lengths? In fourth question, again, we use 6 parts. So fourth question, first part. Fourth question, first part. Now length of 3 sides of a triangle is 8 centimeters, 5 centimeters, and third is 15 centimeters. 8 centimeters, 5 centimeters, and 15 centimeters. According to this formula, add any two sides. 8 plus 5. 8 sum of two sides. 8 plus 5. This is 30. This is the sum of two sides. 8 plus 5 is the sum of two sides. Now third side is 15. According to your fact, sum of two sides is greater than the third side. Now you see 13 is less than 15. 13 is less than 15. It means we cannot draw the triangle with these lengths. It is not possible to draw a triangle of 3 sides, 8 centimeters, 5 centimeters, and 15 centimeters. So here you answer is no. No means you can't draw the triangle with these lengths. Clear, students? Next is part B, 6 centimeter. Part B, 6 centimeter, 7 centimeter, and 13 centimeter. Now again, beta, add any two sides. 6 plus 7. Small side. 6 and 7. 6 plus 7 is 30. And third side is 30. According to the fact, sum of two sides of triangle is greater than the length of third side.